Welcome to the video lecture for section 2.4. This is for MGF 1106. My name is Jorge Gabriel. So 2.4, we're going to talk about survey problems. The objectives are we're going to label sets and Venn diagrams with various names. We're going to use Venn diagrams to solve survey problems. They're going to be able to identify contradictory information in survey problems. So the first thing, we're going to name naming Venn diagrams. So we use set notation to name regions of a Venn diagram. So here you can see that region 4 can be equal to the difference between set B and set A. And region 1 can be the complement of the union of sets A and B. And of course, there's different ways that we can name this. So one of the things that you'll see in the textbook is that they actually shade the regions that they're trying to get you to name. So here's another example. We're going to use the figure to answer the question. What is the set for region R2? So we have here R2, and you can see that R2 is in set A. It doesn't belong to set B or set C. So one possible name for region R2 would be the intersection of A and B prime with the intersection of C prime. Another possibility would be, so you can see that R2 is not all of A. B and C are excluded. So another thing that we can do is we can also do the difference maybe of A and the union of B and C. That's one way to name that. Survey problems. So when we collect and organize data into sets, we usually want to analyze the information. So these types of problems are called survey problems. So a television network conducted a market survey to determine the evening viewing preferences of people in the 18 to 25 age bracket. So the following information is obtained. 3 prefer a reality show early on weekdays. 14 want to watch TV early on weekdays. 21 want to see reality shows early. 8 want reality shows on weekdays. 31 want to watch TV on weekdays. 36 want to watch TV early. 40 want to watch reality shows. And 13 prefer late weekend shows that are not reality shows. So what we're going to do is we're going to organize this into a Venn diagram. So from this information, determine how many people do not want to see reality shows and how many prefer to watch TV on the weekend. So the solution. So the set of people surveyed is a universal set, and it contains 3 subsets. W, those who prefer to watch TV on the weekdays. E, those who desire early programming. R, those who want to see reality shows. So we have a couple conditions. Condition A, there are 3 people in the intersection of W, E, and R. There are 14 people in the intersection of W and E. Condition D, 8 people want to see weekday reality shows. So 5 people have not been counted in the intersection of W and R. Condition, that should be condition C, 18 have not been counted in the intersection of R and E. There are 12 more members in W, 4 more in E, and 14 more in R. Now, condition H, there are 13 people outside of W, R, E. So that's in the universal set, but not in sets W, E, or R, or E. And so no reality shows ends up being 40, and preferred TV on the weekends ends up being 49. So these, the first time you see this, it probably seems confusing, but after you do a couple of these, you kind of get the hang of them, and then you understand how to kind of put them together. And sometimes there is some information that doesn't make any sense, and that's when you have to sort of say, well, this is not going to work. So this is the next thing, which is exactly what I just mentioned, inconsistent survey data. So suppose that an internet blog states the following information concerning which music streaming service its members use. 316 use iHeartRadio, 478 use Spotify, 104 use both iHeart and Spotify, 567 use only one of these services. So we're going to find what is inconsistent in this data. So we begin by drawing the Venn diagram. So we're going to let H be iHeart users, S be Spotify users, and the figure shows that 104 people use both services. Now, because H contains 316 elements, this means that 316 minus 104 is 212 elements. So 212 elements are in the difference of H and S. Now, 478 minus 104 is 374 people only use Spotify. So the difference of H and S contains 374 elements as shown below. So according to the figure, 212 plus 378 is 586. So we're going to use only one of these 2 services, which contradicts the condition D. Therefore, the data that we have is inconsistent. So somewhere along the line, you'll find something that doesn't make any sense. So the next example, surveying media users. A media company that produces Pilates videos surveyed its customers to determine whether they would prefer to purchase the videos by buying an access code to allow them to download from a website, purchase hard copies on a DVD, or access the videos via podcast. The company has extracted the following table of information from its customers' database. So A, we're going to find the elements in the union of M and D. We're going to find a number of elements in A prime. So here we have this table. So the cardinal number of the union of M and D is equal to the elements in M. The cardinal number of M plus the cardinal number of D minus the cardinal number of the intersection of M and D, and then we get 100. And then for B, the cardinal number of A prime would be 63 plus 22, which is 85. And that's the end of section 2.4. Thank you.